Lesson 6.5 is split into 2 days. So day 1, we're going to talk about solving proportions. So there are 3 warm-up problems here. I just want you to try the first 2 on your own. Then we'll go through them together and start on the lesson. So number 1, it just says determine whether this is proportional or not. So we have whole pizzas and slices of pizza. So 1 whole pizza is 8 slices, 2 whole pizzas, 16, 3 whole pizzas, 24 slices, 4 whole pizzas, 32 slices. So we're just checking to see if this is proportional. So again, we take top divided by bottom, and here we have like 2 sides. So what I'm actually going to do is I'm going to take the right side divided by the left side. And I'm going to do that just because my numbers are going to be a lot nicer. So I'm going to take 8 divided by 1, which is 8. I'm going to take 16 divided by 2, which is 8. I'm going to take 24 divided by 3, which is 8. And again, we want to check every column when we're seeing that it is constant. 32 divided by 4 is 8. So then the sentence for this would be, it is proportional because the rate of whole pizzas to slices of pizza is constant or is equal, right? They're all 8. Number 2 says we're comparing whether the time and the distance is proportional. So again, I'm going to do right side divided by left. You could also do left divided by right. Doesn't matter. So I'm going to take 23 divided by 5, and we can use the calculator. 4.6. 28 divided by 10. 2.8. So we already have that it's not proportional, so we don't have to keep going. Okay? Your sentence could be, this relationship is not proportional because the rate of time and distance is not constant. Okay, so vocab, proportion, an equation that states that 2 ratios or rates are equal. So again, we talked about if something is proportional, those rates are equal. So when we're looking at just numbers here, this is an example of a proportional relationship. It tells us that these 2 fractions are equal. 2/3 is the same as 8/12. Those are proportional, right? Because it's the same thing. If we simplified 8/12, we get 2/3. So same thing with this, 5 over x equals 8 over 12. Well, this relationship is also proportional. It tells us that by that equal sign. It means that both of these, if we were to turn them into decimals, they would both be the same thing. They are proportional. So to practice solving a proportion using equivalent ratio. So at the top of your notes, it says solve the proportion by multiplying the numerator and the denominator by the same number, making equivalent fractions. So make sure your answer makes sense. So in your notes, you could write down 5/6 equals x over 18. We know this is proportional. We just got to figure out what x is to make this proportional. Well, I know that on my denominator, 6 times 3 is 18. Whatever I do to the denominator, I have to do to the numerator. 5 times 3 is 15. So I know that x is 15. 5/6 is equivalent to 15/18. Those are proportional. So that's one way to check. So in that same portion of your notes where it says solving a proportion using equivalent ratios, we're going to try 2 problems. 2/7 equals x over 21. Well, I know that 7 times 3 is 21. So I'm going to do that same thing to the numerator. 2 times 3 is 6. So I know that x equals 6. And then just double check, does my answer make sense? 2/7, 6 over 21. Yep. X equals 6. Okay, then we have x over 2 equals 20 over 10. We can go either way here, right? Before we had the left side and we multiplied that to get to the right side, but we can do the same thing right to left. Actually, no, we're going to do left to right. I'm going to do 2 times 5. Actually, no, I'm not. I'm going to do, take it back, right to left, like I said earlier. I'm going to do divided by instead of multiplied because I know that 10 divided by 5 equals 2. If I divide the denominator by 5, have to multiply the numerator by 5. 20 divided by 5 is 4. So I know that x is equivalent to 4. 4 over 2 is the same as 20 over 10. Okay, so we can also solve a proportion using algebra, doing the inverse no, we're going to skip that. Okay, so in your notes it says solve a proportion using unit rates. So in your notes I want you to write down this. X over 3 equals 20 over 10. Okay, what we can do here is we can also look to see, look at the numerators and denominators. I know that 10 times 2 is 20. So I'm going to do that same thing, denominator to numerator, times 2. And I know that 3 times 2 is 6. So 6 over 3 is equivalent to 20 over 10. So that's just another way to solve for x. We can also, you guys, solve just like we were before in chapter 4. To get rid of a denominator, we can multiply. So c divided by 12, the opposite of that would be multiplying by 12. Those cancel and I'm left with c equals, change this to 12 over 1, cross simplify. Divide by 4, so I get 2/3. 2 times 3 is 6. 2 times 1 is 2. So I get c equals 6 over 2, which is equivalent to 3. So 3/12 is equivalent to 2/8. Okay, and then what we're going to talk about is solving using cross product. And this is what we're going to use probably the most. So cross product tells us that we can multiply the numbers that are across from each other and solve that way. So in your notes, I want you to write down this problem. 2/5 equals n over 6. So cross products tells us we're going to multiply the numbers that are across from each other. So I'm going to take 5 times n equals, and set it equal, 2 times 6. Well, 5 times n is 5n equals 2 times 6 is 12. And then I'm just going to solve this algebraically. So 5 times n, the inverse of that is division. I'm going to divide both sides by 5. And I get n equals 12/5 simplifies to 2 2/5. So we can solve using cross products. Let's try again. 8 over n equals 20 over 12. Again, solve using cross products. Multiply what's across from each other. 20 times n equals 8 times 12. 20 times n is just 20n equals 8 times 12 is 96. And then to solve for n, I'm just going to divide both sides by 20. And I'm left with n equals, and then I'm just going to simplify this. Let's see, 20 goes into 96 4 times. 16/20 would be left over, which would simplify to 4 and 4/5. There is our value of n. So again, cross products, that's probably what we're going to be using the most. So this says solve proportion using measure spaces. So like using a chart. So in your notes, I want you to copy down that chart, baseballs and cost. And then it says 2 baseballs cost $5. How much will 7 baseballs cost? So these charts come in handy just to kind of keep things organized. So when we have 2 baseballs, we have $5. And I'm going to add on labels here. 2 baseballs, $5. How much will 7 baseballs cost? So then I'm going to do 7 baseballs is how much? X. We don't know. So we fill in the labels and numbers and then find the relationship across a row or down a column and apply that relationship to the other column. So here, looking at 2 and 5, 2 and 7, there's not like a clear relationship here. So what I'm going to do is I'm going to use cross products to solve. I'm going to take 2 times x and 7 times 5 and set them equal to each other. So I'm going to take 2 times 5, which is 10, and set that equal to, oops, not 2 times 5, I'm sorry, 7 times 5, which is 35. And set that equal to 2 times x, which is 2x. So again, the numbers that are across from each other. Then I'm going to divide both sides by 2, and I get x equals, and then it would be $17.50, and I want to make sure I have a label, $17.50. So 7 baseballs would cost us $17.50. The next problem says for every $25 that you earn, you save 15. How much of the 70 that you earned at your school will you save? So we're comparing here saved and earned. So I'm going to make a table. And I'm going to do save and earn. So looking at my first statement, we earned 25 and we saved 15. So I'm adding labels. So I earned 25 and I saved 15. Okay, and then the second part says that we earned 70. How much are we going to save? So I earned 70. I'm going to figure out X, how much I'm going to save. Making sure that I don't switch those around. That's why it's good to add labels and good to have this table where we have save and earn so that we don't get our numbers mixed up. Now we are going to use cross products, and I'm going to take 25 times x, which is 25x, and I'm going to set that equal to 15 times 70. 15 times 70 is 1,050. Okay, then to solve this, I'm going to divide both sides by 25. And I'm left with x equals 42. Add a label. So we will save $42. And it's always good to double check, does that make sense? So when we earned 25, we saved 15. So we saved less than, right? When we earned 70, we saved 42. You have to save less than the amount you earned, right? If you got an answer of like $100, well, how would you only earn 70 and save 100? So we save $42. Alrighty. And then this next one says you need 1.75 cups of lemon juice to make 14 servings of lemonade. How many cups of lemon juice are needed to make 4 servings of lemonade? So we can set up a table here, and it doesn't matter which way you do it. So I'll do it the opposite way this time. We'll do cups of lemon juice and servings. And I'll just abbreviate that by doing serve. So we know when we have 1.75 cups of lemon juice, it makes 14, whoops, put it in the wrong column. See, this is why it's good to do columns like this to double check. 14 servings. Also important to add labels, and that's why. So I just caught myself. I was in the cups column and I put servings as my label. So I knew something wasn't right there. So then it says how many cups, so that's going to be our X, are needed to make 4 servings. So I'm going to put 4 servings in the servings column. We're going to set up a proportion and solve using cross products. So I'm going to multiply these numbers that are across from each other. X times 14 is 14x equals, and then I take 1.75 times 4. 1.75 times 4 is 7. Then I'm going to divide both sides by 14. And I get x equals 1/2. Make sure that I know what I'm labeling it. It's going to be 1/2 a cup. Okay, so for 4 servings, we need 1/2 a cup of lemon juice.